Okay, so today's class, we are looking at ionic compounds. We'll look at properties of ionic compounds. We will look at formulas and naming ionic compounds. So when an atom gains or loses electrons, the atom is no longer neutral. It has now become an ion. So an ion, it has a positive or negative charge. So what we know from atoms and why they were neutral was because they contained an equal number of positive and negative charges. So for example, oxygen, which is element number 8, therefore it had 8 protons, and therefore it would have 8 electrons, making it neutral. But once oxygen gains electrons, it now becomes an oxygen ion, or an oxide ion. All right, so that's what an ion is. And then next are the compounds, the ionic compounds. So ionic compounds are formed from a metal plus a non-metal. Right, that's very important because we looked at molecular compounds before, and we know that molecular compounds form between a non-metal and a non-metal. All right, so here, what we're looking at here is sodium, right here, which is symbolized with Na. So a sodium is number 11. It has atomic number 11, so therefore it has 11 protons. But, so it has, 11 protons and 11 electrons. That's a sodium atom. But it loses one electron. So when it loses one electron, it will still continue to have 11 protons because that's what makes it sodium. But it will now have 10 electrons. So because it lost an electron, it now became one positive. All right, so if you look at the periodic table, you'll see Na plus, meaning Na has a 1 positive charge. All right, where does that electron go? If it was in this case here with chlorine, chlorine will take that electron. So chlorine now becomes a 1 minus. It will have an extra electron, so therefore it now has a 1 minus charge. All right, and that's how the ionic compound of NaCl would be formed. All right, and then sodium chloride is commonly known as table salt. All right, so just some properties of ionic compounds. They are pure substances formed as a result of the attraction between particles of opposite charges, which are called ions. Again, an ion is an atom or a group of atoms that's become electrically charged through the loss or gain of electrons. So these ionic compounds, they have high melting points. They are good conductors of electricity, so they have the ability to carry electric current. So if an ionic compound is melted or dissolved in water, it will conduct electricity. The reason being is those ionic compounds, they will separate into their positive or negative ions when they dissolve in water, and then charged particles can carry an electric current through the water. And this property is what led to the invention of batteries. Ionic compounds also have a distinct crystal shape, and they are solid at room temperature. All right, so when you see an ion and its charge a plus positive sign like this or a minus sign like this, it's placed to the upper right of the element symbol as a superscript. So if you look at your periodic table, you will see Na positive and chlorine is Cl minus. So one other thing you'll see on the periodic table are these called polyatomic ions. These are a group of atoms acting as one. So for example, there's a carbonate polyatomic ion, and it is CO3 2-. All right, so CO3, and then its charge is 2 minus. So it's got 1 atom of carbon and 3 atoms of oxygen, and its charge is 2 minus. And when a carbonate reacts with calcium, the product is calcium carbonate, which is also known as limestone. And this is its chemical formula, CaCO3, with the little subscript there with of S showing it's a solid. So just going back here to show you that, up at the top of this periodic table is this chart here called the table of polyatomic ions. All right, so you go down here, it's alphabetical, you'd find carbonate, and you see it here at CO3 with a charge of 2 minus. All right, so here it is just showing the polyatomic ions. This chart here, we're just looking at the charges that we would see in the periodic table. So for example, oxygen has a 2 minus charge. That means it accepts 2 electrons. And then that's the notation, all right? So it's a superscript when we write the charges. Top right corner showing the superscript like that. The other thing to notice here is iron, copper, and lead. They have 2 charges, and that's called having multivalent charges, but we'll talk about that in a little bit. Okay, so what we're going to talk about next is how to name ionic compounds if you are given its formula. All right, so step 1, the name includes both elements in the compound. The name of the metal comes first. All right, so the metallic element is named first. The second element is going to be your nonmetal. That comes second, and we change its ending to "ide," just like we saw in the molecular compounds. Next, we will also see subscripts. These indicate the ratio of ions in the compound, all right, but we do not use prefixes for ionic compounds. So no prefixes here. This is CaCl2. It is just called calcium chloride. All this is showing is there's a ratio of calcium to chloride ions of 1 to 2. All right, so again, the name of the compound does not indicate the number of ions of each element. So therefore, there's no prefixes being used. So if we had NaCl, it is just called sodium chloride, right? We change the ending to IDE. It is not sodium chlorine. NaF would be sodium fluoride. LiCl, that would be lithium chloride. And ZnS, that would be zinc sulfide. Okay, so again, the metals are named first. You keep the name as is. The non-metal element is named second, and we change its ending to "ide." All right, here are some examples. Let's try these. So for our first example, we would find Zn in our periodic table, and Zn is the element zinc. It is our metal. Next, we would find N, which is nitrogen. It is our non-metal. Okay, it's on the right-hand side of that staircase. So now when we name this, we name our metal first. We keep it as is. So it's just zinc. And then for nitrogen, we change the ending to "ide," so it becomes nitride. So the name of this compound is zinc nitride. All right, so naming our next one here, Li, we're going to find that on our periodic table. So Li on our periodic table is lithium. And it is the metal. O is oxygen, and it is the non-metal. All right, so when we name this, we name our metal first. So we call this lithium. And then we have oxygen. We have to change its ending to oxide. All right, so the name is just lithium oxide. So again, please note, we do not use any of the prefixes that we were using for molecular compounds. We do not use di, tri, mono, or any of those prefixes for ionic compounds. All right, so our next one, we're going to find Mg on our periodic table. All right, so I'll just do a quick going back to the periodic table. So we're looking for Mg. Mg is right here. It is magnesium, and we are looking for Br, which is bromide, which is right here. All right, so again, it is a metal and a non-metal. All right, so Mg was magnesium. And that's our metal. Br is bromine, which is our non-metal. So when we name this, the metal comes first, so magnesium, and then bromine, we change the ending to bromide. All right, so looking on your periodic table, you're going to look for aluminum. Al is aluminum. So Al is aluminum, and it's the metal. S is sulfur, and that's the non-metal. All right, so when naming this, we start with our metal. So aluminum comes first, and then sulfur, the ending changes to sulfide. So sulfide. All right, so next in ionic compounds is writing the chemical formulas. All right, this is one method that's shown here, but I'm going to show another method that's called the crisscross method. All right, but the first step is the same. Print the metal element symbol with its ion charge. Next to it, you're going to print the non-metal element symbol with its ion charge. So in this example, we have calcium, which has a 2+ charge. Chlorine has a 1- charge. So here what they've done is they're balancing the ion charges. All right, so for every calcium ion, there has to be two chlorine ions to give us our chemical formula of CaCl2. But like I said, I'm going to show a different method, which is called the crisscross method. All right, so let's just go back to this calcium and chlorine. All right, so let's just do it right over here. So the first thing we're going to do is write out our element symbol with its charge. So calcium has a 2+ charge, and chlorine has the 1- charge, which is just shown as a minus like that. The crisscross means you're going to take the charge is always written top right corner. You're going to take it and we are going to crisscross it like this. All right, so that becomes a Ca. The minus is just shown as a 1 here. We don't write the 1. And then chlorine, the 2 comes down like that. Once you've crisscrossed and you write the numbers as subscripts, if you can reduce, then you would reduce at the end. Otherwise, you would just leave it like this. So let's take a look at a few more examples here. The first example we have is aluminum oxide. So aluminum has a 3+ charge. Oxygen has a 2- charge. We're just going to crisscross. All right, so the 3 comes down as a subscript for O. The 2 comes down as the subscript for aluminum. And if we look at our name, it is just called aluminum oxide. Here's another example. We have barium. Barium has a 2+ charge. and chlorine has that 1 minus charge. So crisscross, the 2 moves down as a subscript for chlorine. The 1 is a subscript for barium, but again, we don't show that 1. I'm looking here at magnesium. So magnesium had a 2 plus charge, bromine has a 1 minus charge, so crisscross. That gives us Mg with the Br2. And it's called magnesium bromide. All right, so for magnesium phosphide, we've already wrote down our charges for magnesium and phosphide. So now all we have to do is crisscross and bring the numbers down as subscripts. So this becomes Mg3 and P2. All right, notice they are written as subscripts. Okay, it's very important that they are being written as subscripts. All right, for our next one here, potassium chloride. Potassium is a K plus, chlorine Cl minus. So just crisscrossing the ones there. Because they're just ones, we don't have to write them. So it is just KCl. All right, last one, calcium oxide. So our next example is calcium and oxygen. So calcium is right here, 2 plus charge, and oxygen is here with the 2 minus charge. Okay, so writing that out is calcium 2 plus, oxygen is 2 minus. Next, we're going to crisscross. Okay, that becomes Ca2O2. But we are able to reduce these 2's into the simplest ratio. So it becomes just CaO.